All right. Hello, everyone. Welcome to the midterm review session for CP164. Hopefully, everyone's doing fantastic this evening. And yeah, so I'm your host, your co-host, actually, one of your co-hosts, Robert Mazza. I'm a third-year computer science student here at Laurier, and with me today is his first time on a review session. Steven, if you want to introduce yourself.
Hey, how's it going, everyone? My name's Stephen Tome. I'm a second year BBA CS student here at Laurier as well. And I'm excited to be hosting with Robert today. So hope you have a good time.
All right, yeah. So today's obviously the review session for 164. And jumping into what we're going to be covering. We're going to be kicking it off with the review of some of your past sessions. If you haven't been to them, that's fine. We'll be covering the concepts today. The sessions were the first session is going over ADTs and classes in Python. And then the second session is jumping into more of the data structures like the stacks, queues, and lists. And then we're going to be rounding it off with some of your new content like the Big O and Recursion near the end. And before I go any further, I want to shout out that LCS is doing a Meet the Professionals event next week on the 16th. It's a recruiters edition, so we're gonna have some great speakers coming from some tech companies talking about recruiting and how to land that tech job interview in big tech. So definitely come out to that. Stay tuned on the socials, on the Instagram mainly for that stuff. So yeah, I think there's gonna be more information released on that soon. And as always, here are some of our useful links and follow along resources. If you guys haven't, if you guys don't follow along with us, we usually give this at every presentation. Some good resources linked here on screen if you guys want to take note of them. But otherwise, I'm going to move on into our review session 1 recap. So, classes, data structures, and abstract data types.
All right, so we're going to start off just how we started off with the first review session, talking a little bit more about classes. So we're going to speak about like what they are, um, what class attributes do, and what class methods do. So starting off with what are classes. So a class is pretty much a blueprint for creating an object. Classes are defined. They define the data and behavior of each object through variables, which are the attributes of the objects, and functions, which are the methods of the objects. Each object reuses the properties from the class, so that's why we call it a blueprint. And it allows us to make projects we build more modular. So we can take an object and a class and use the object from that class across an entire project to make everything more accessible and more uniform for the user. So let's talk a little bit more about the attributes. So the attributes within a class can be defined as public or private. So public attributes are accessible through all of the objects in the class. If a user has object access to the object, they have access to these attributes as well. And private attributes remain hidden in the class. And methods can also be public and private. So it's not just an attribute or, yeah, it can be used for functions as well. So for methods, there are a few methods that classes can have. So constructors, these are what builds the objects. Accessors, these are to access information stored in the objects. Mutators are to change any information stored in the object. And an iterator, which goes through the information. So just a really quick example that I like to give, and why it shows a car on this slide, funnily enough, is so a class that we like to describe is kind of like a car. So the attributes are maybe like the year it was built, the model of the car, what color it is, horsepower, for instance. And the methods, so a constructor would be like the factory, so where the objects are built. The accessors and mutators and iterators could be like driving a car, for instance. So
Right now. And I just realized too, we missed the sign-in slide here.
oh, that's true.
So I'm gonna back up real quick. And I'm gonna start from here. So if everyone's, I guess that was a little teaser, the presentation. But before anything, everyone use the sign-in link here or scan the QR code, and make sure to sign in to the session. If you guys just want to quickly pull that up on like a different tab or something, and then we'll jump right back into it. The link's also in chat. I'll give it about another 10 seconds and I'll jump back to where we were. Alrighty. Okay, this is also another slide that we missed. We're currently at the midterm review. We're going to be having 2 more sessions, review session 4, and then your final review. So let me just jump back in to where we were. Classes, yeah. All right. And then, so the next section after classes, we have data structures here. So what are they? How do we make them? And why do we use them? And to answer quickly in chat, yes, the previous videos are accessible on our YouTube channel. So what are data structures? So data structures are objects that efficiently store data to perform certain operations on them. So I know that's really vague and very hand wavy, but I'll explain. Some examples, as we see, are stacks, queues, arrays, trees, and more. So imagine it's an object in a way. Thinking about it as like a way of storing data that makes it easier to use the data that you're storing. So, there's different data structures, as will see from stacks and queues, that you have the same data, let's say, in each one of those things, but then the way that the data is stored makes that data usable in different ways that can be useful for solving different problems, as we'll see coming up. So how do you make them? So Python provides a built-in implementation of certain data structures, like lists, tuples, sets, and dictionaries. So, for example, in Python, right? If you just use like the open close square bracket notation, you're creating a list. But what's really happening is on the back end of the engine of the programming language is going through all the work in the memory to make that list a thing, which you don't have to do. And Python doesn't have built-in stacks, queues, and trees. So it's up to you to implement those data structures, and that's what you guys have been doing throughout your course. So how do we use data structures? So when a programmer uses a data structure, they can leverage their features to create even more complex programs. Data structures can be used to solve complex problems in a more efficient way. So let's say you need to do something where it's really important that the things that come into, or things that get created, are executed in a certain way. So let's say you're writing a program where you have things that get queued up, that's a little hint, for something to be processed, and it needs to be processed in the order that those things appear or get fed into your program. Well, I said the name already, but there's a data structure that'd be really good at doing that, and it would be called a queue, right? So just like that, that's one example of a data structure. But other things like stacks and trees have all sorts of different uses for building complex program that really need to sort your data and have your data accessible in different ways.
So now we're going to move on to abstract data types. We're going to talk about what abstract data types are, a little bit of the important concepts, and we'll just follow up with an example to just wrap up the abstract data types and data structures as well. So an abstract data type is a container that describes how data is stored and what operations can be done on that data. It doesn't describe how the operations are implemented, but so Python provides built-in types such as ints, strings, and floats, and abstract data types are pretty much like their own types. So they're their own types that we can define, and we're just going to show you an example of the syntax right after we finish some of the important concepts. So modularity is a big thing. ADTs can be used as a black box without the user seeing how they're implemented internally. So modularity means that they can be used all over a program without the user really knowing what's happening inside as well. Information hiding, that's the same concept almost. The user only sees what they need to know. The interface is also implemented with abstract data types. So the part of the module that's visible to the end user is called the interface. And encapsulation is wrapping up all the parts of an entity in a module and restricting access to the underlying class or ADT. So let's just look at the example of how we create an abstract data type or data structure. So first of all, we start very basically. Every class in Python is started with a class keyword and then the name of the class. Usually it's capitalized just for syntax. And then we have the init function. So inside of the init function, we would have the attributes that we talked about before and how they're defined. And then the push, pop, peek, and is empty are all methods that we can implement however we want using the attributes that were given to the data structure. So yeah, that's pretty much how to implement one.
All right, so hopping into the recap of review session 2. So this is where we jumped into stacks, queues, and lists in case you missed it. And to kick us off, stacks. So what are stacks? A stack is pretty much a data structure where data is stored and retrieved. The last element inserted is the first element removed, known as LIFO, or last in, first out. So if you can see almost like the stacks on the right there, those pallets, that pallet, when you add a new pallet to the top of the stack, if you were to go take a pallet, you would probably want to take the pallet off the top of the stack, or else the whole thing is going to come crashing down on you, right? So this is the whole idea of stacks, is that when you add an item, it adds to the top of the stack, and when you remove an item, it comes off of the top of the stack. So we're not removing from the bottom, the middle, or anything. We're putting onto the top and removing off of the top, and that's known as LIFO, which is last in, first out. So here's a little illustration of what that kind of looks like from an empty stack. So here we have an empty stack, and we'll push an item onto our stack. So this is number 1 in this case, and this gets added to the bottom of our stack. And when we go to push another item onto the stack, push is obviously the method that you would use to add things to a stack. It's called push. And when we push for a second time, we see that it gets added on top of the first value. So this is going to be the new top of our stack. It's number 2 here. And then we'll push again, and we can see the same thing happens. And now we have a stack of 3, 2, 1, with 3 being the top of our stack. So when we go to remove something out of the stack, we call what's called the pop function. And pop is responsible for removing the top of the stack. So we see here that 3 gets removed off the top of the stack with pop. And this is important because this is our last in, first out I guess algorithm here, or the way that the stacks work. We can see that the first thing that we added to our stack is 1, and it's still at the bottom here. And the last thing that we had added was 3, and we could see that that was the first thing out. So that's last in, first out. So why are stacks useful? The first reason why stacks are useful is because in a lot of situations, you might have seen them use, like in your kitchen, in, like, let's say in your kitchen sink with like dirty dishes or something like that, or Home Depot with stacks of pallets, as we saw in the video before on the side, or even a football game. I'm not sure what the football game example is. I can't remember it off the top of my head. But anyways, the most popular way that stacks are used in programs are for backtracking or calculating math expressions that use BEDMAS, and there's many more. So with backtracking, I'm sure everyone has made like some stupid error in, maybe when you're coding or, writing an essay or something, and you use Control Z or the undo function. you could thank a stack for that, because stacks are really good at doing that. That's called backtracking. So you could think of it as like the last change you made was the first change to be removed. That's kind of how the undo redo function works in a lot of programs. And so here's the implementation of our stack. We can see that we initialize our array-based stack with an empty list. And then we have our push function, which now appends a value to our list, to the end of our list. And then our pop function will pop from the end of our list, and our peak will simply show us the value that's at the top. And note that we're using the notation, like the negative notation, for calling the values from the list, because it's important to note that with the array-based implementation of a stack, when there's values added to our list, the last value, or the value with the highest index, is considered our top, and the value at the 0 index is considered our bottom of the stack. So that's why we're looking at peak here, removing or looking at the very last indice from the right.
All right, so we're going to move on to queues. So a queue is a data structure where data is stored and retrieved such that the first element is the first element removed, which is FIFO, first in, first out. So it's pretty much the opposite of a stack. So whatever comes in first is also removed first. So there's a little explanation on the next slide. So these functions for inserting and taking out from a queue are called DQ and NQ. So NQ is adding to the rear of the list, and DQ is taking out from the front. So if you see here, 1 would have been the first element added, and then 2, and then 3, and then 4, and then 5 using the NQ function. And when the DQ function is called when all 5 elements are in the queue, it's the first item to be taken out. So why are stacks useful? Queues useful, my bad. Queues are useful in cases where the first element needs to be processed first. Examples of this are printers, uploading pictures, operating systems, jobs processors, and a breadth first search. And so, like we can see here with an ice cream truck, if we don't tend to the customers that are first in line rather than the ones that are at the back of the line, so the people who come first to the ice cream truck, we need to tend to them first, or the people at the front will start to get angry if we tend to people behind them. So that's kind of a real world usefulness of a queue. And here we have a queue implementation in Python. So we start off pretty much how we started the stack with initializing the values. So it's just a list here. Our enqueue function is also the same as a stack because we're just adding. And the pop is also the same. We're taking out from the start of the list. And here for our peak value, we want to look at the first value of the list because that's the value we care about. With the stack, we cared about the last value because that would have been the first value to be taken out. And we just have a return values function, so it's easier for examples later on. So that's queues pretty much.
All right, so jumping into the list now. This is our final data structure. So what are lists? Obviously, you guys are probably super familiar with lists now, even since the end of CP104, I believe you guys started using them. So a list is pretty much your data structure where data is stored as a collection of sequential elements, each consisting of a unique index of its position. So if you're familiar with lists, essentially that's when you use your square bracket notation and then you use commas to separate the values, and you have your indexes that identify the position of each value you have in your list. So let's visualize what this looks like. So we have here a list containing 5 values, and we start at the index 0, of course. When we count using a list, we start at 0 and then count up from there. That's why we have 5 values, but it's only up to 4 because we start at 0. And we can see that we're storing 5 different numbers here, all in order. Now, like I said, lists are great for storing or combining data into, I guess, like one package, but while still having it separated through the index system. And why are they useful? So lists are probably one of the most useful and widely used data structures, and we can see that because we just implemented stacks and queues using lists, right? We saw the square brackets used in both of those other examples, and at the core of that is our lists. So we could just see how useful they are just from the other data structures that we've been looking at. And just, yeah, I don't have anything else to really add to that. They're just super useful. And if you guys haven't already, I guess, figured that out through, all your coding and stuff, you definitely will soon. And so here's an example. We have, this is the example of, I believe, an implementation of the list. We don't have a title on the slide. But here we can see that we initialize with an empty array, an empty list, and then we have the get item. I don't remember what get item is. Sorry, when you use the bracket notation with the I when you pass the index. So that'll make a copy of whatever value is in that index position. And then length is when you use the len, like the len function, if you want to ever figure out the length of a list. And we're simply just calling that again here. And so we go down here. This stuff isn't really important to know for your midterm, I believe, but definitely do know append and peak for sure. Append will add the item to the new item to the end of the list, and peak will just show you the first value of the list. So we can see here.
Okay, so
jump into some examples.
Yeah, I can take us through the replit examples. One sec, let me just share my screen really quick. I hope you guys can see that.
Yeah, one sec, just give me a sec to pull it up. All right.
You're good, Rob?
Yeah, you're good.
All right. Okay. So here, this portion right here is the stack example that we showed previously on the slides. So, so after we define the stack class, we're defining another class called restaurant. So this example pretty much is how Rob was talking about your kitchen sink, where you add a pile, where you have a pile of dishes. The first ones that are added to the sink are most likely the first ones that are going to be cleaned. So we have a restaurant sink here. Its attributes are plates, which is a stack. So we're using this class structure in the definition of this in this class. So we have a method called add plate, which pushes an item onto the restaurant stack. A remove plate, which pops the last last item to be added to the stack out, and the peak to check which item is going to be popped next. So here we initialize a restaurant object as rest. And so we add plate 1, plate 2, plate 3, plate 4, plate 5. And if we run this, we can see that plate 5 is on the top of the stack. So here we remove the plate and print top plate has been removed. And now if we check which plate, which is just peaking at the top value, we can see that 4 is now the top plate. So the last plate that was put in was plate 5. It's also the first plate that is being removed and cleaned. So that's how a stack works. If we were to remove more, it would show that plate 3, then plate 2, then plate 1, and then at the end, there would be nothing left in the pile. So it just goes from last to second last, third last, and so forth. So that's the stack example. We can look at the queue example really quick. So same thing here. We are just defining the queue class. And this example is about a grocery store. So when you pass items through a checkout belt, you put items in, and the first item to go in is the first item to get scanned and be put in the cart. So here we define the grocery store checkout belt with an items attribute, and that's a queue. Add item to belt, we enqueue the item onto the queue. Remove from belt, dequeue the item, so removing it. View item, we're just peeking at the one that's next to be removed. And view belt just returns all the values, so it's easier for us to see in the tests. So the items on the belt, when you first put them all on, you put it apple first, then orange, then banana. So that's a list here. We're just adding them onto the list here. So first of all, we display all the items with view belt. So we see apple, orange, banana are the items on the belt. And we begin scanning the items. So this is now we're scanning it and we're putting them in the cart. So item 1 was scanned first. As we can see here, remove item from belt, and apple is the one that's removed because it was the first one put on the belt. Orange, banana, and then we do the same thing again with item 2, and it's just banana. And item 3, there's nothing left on the belt. So first in, first out. That's just the basic nature of a queue. And so list, I'm sure you guys have all used list before, but maybe not in the way that you have to create them on your own with a data structure. So here's just a list implementation. And so this example, we have a diary, which is just our own data structure of a list. New entry, we append the value to the end. We peek, but the day value, this is where the peek function differs from stack and queue. We can give it an index, and it will return the value at that index. We can edit an entry as well at a certain index. So we give it index called index, and an edited value. So we give the function an index that we want to be changed, and the edited value will be the new value of that index. And return entries is just to view all the entries. So we create a new diary with the diary constructor, and this is just our list of first entries, so it's just some mumble. And then we're adding it with the new entry, and here we're seeing diary entry 0 is reviewing the entry 0, so this would return this one. As you can see in this list, the index obviously starts 0, 1, 2, 3, and now we're editing entry 0 to, hey, this is a new entry. And so using the view entry, we can see that the entry at index 0 is now, hey, this is a new entry, and lorem ipsum dolor, whatever, is no longer at entry 0. So that's how a list data structure works. So yeah, those are a couple examples
Sweet.
of real world applications. So
Someone in chat's asking if we have any practice problems that are available. We don't, but I will say that like your labs and assignments are a great place to go if you haven't already mastered those. If you have mastered those, that's fantastic. And try websites like HackerRank and LeetCode, but stay on the easy problems and make sure that you're looking at like the data structure problems and coding it in Python. That's like the only additional thing that I would say. That's what I did in first year.
yeah, and speaking of HackerRank, actually, Robert, sorry to interrupt,
Yeah,
but you guys also get a bonus mark, I'm pretty sure, if you do HackerRank, like certain HackerRank problems. And those are there for you guys to practice for midterms and exams. So they're a really good resource to go to if you guys want any extra practice.
wow,
So yeah.
that must be new.
Yeah. Yeah. It wasn't even a thing when I was doing it like last year. But yeah.
Yeah, so definitely check out HackerRank. Especially get that
Yeah,
bonus mark too. You could get two birds with one stone. You could study for your exam and get that bonus mark.
exactly. Yeah.
All right. So I believe the next stuff is we're jumping into some of the new stuff we haven't covered before, which is Big O.
Mm-hmm.
Big O theory. All right. So
Yes.
you wanna run
Okay.
Big O? You could run Big O and
Yeah. All right. Cool. Okay. So Big O theory, we're going to go over what is Big O and Big O notation in particular. So first of all, what is Big O? So Big O analysis is used to analyze the efficiency of a given algorithm. The lower the Big O, the more efficient the algorithm is. So with this chart, we can see, so input size is on the bottom. So this is like tending towards infinity. So when n gets closer and closer, larger and larger, going to infinity, this is how each of the Big O like efficiencies will react. So this is just running time on the y-axis. So O of 1 will always, always, always be constant, and it's called constant time. So regardless of how big the input that you're giving to the function is, the runtime for the function will always be the same. Log n, as we can see here, it's always very close to the x-axis because it doesn't really change that much. Because if you think about it, when you take the log of a larger number, it's still going to return a relatively small number. So log n is still relatively an efficient function. So then we move on to linear, which is slightly less efficient. As the input size grows, the running time will grow linearly. So it will grow proportional to how much the input size is growing. So it's 1-to-1. And n log n, it's not really that common, but it's just multiplication. If you were to multiply the time complexities of these two, it would result in this. And these are not as useful. Actually, n to the power of c is pretty useful. This is for nested lists, which we'll look at in a little bit. So just a few common big O time complexities, like we talked about: constant time, linear time, logarithmic time, and exponential time. So we're going to start from best to worst. So constant time. So this is a function that will always return the same efficiency regardless of how big its inputs, which are a and b, are. So if we can see here, the addition function always is a constant. It always has constant efficiency, regardless. Like if you take a number that's 1,000 plus 1,000, it'll be the same efficiency as if you did 1 plus 1. Same with infinity times infinity, actually. But it'll always be constant because that's just the nature of the plus operator. So for linear time, the most common example of linear time is for loops. So let's say you have a list of length n. The time complexity O of n means that you're going through every single element regardless. So the bigger the list gets, the more time the algorithm is going to take. So for the for loop, this will always be the case. A for loop's time complexity will always be O of n. A while loop can also have time complexity of O of n if it doesn't change the inputs into the while loop, which we'll look at right now with logarithmic time. So if we look here, this while loop, it's while I is greater than 0. But usually this would be, what's it called? Sorry,
infinite?
linear time. But since we're changing the I variable, dividing it by 2 each time, it will have logarithmic time complexity because the input is getting smaller and smaller every time. So it's not going to be linear, it's going to be getting smaller. So this one is more efficient than the linear time. But keep in mind, while you're analyzing functions, that while loops can also be linear time. So if this while loop was I greater than 0, but the I isn't being changed inside of the while loop, like if it's only being decremented by 1, for instance, it'll still be linear because it's not being divided. It's not being like cut. Yeah.
Yeah.
So next we move on to exponential, and this is nested loops. So when you have a nested loop, you always multiply the time complexity. So let's say you have a for loop and another for loop. The first one has a time complexity of O of n, and the second one also has a time complexity of O of n. So their combined time complexity would be O of n squared because you're just multiplying them. And like how we saw before in the chart, there's also another time complexity that's O n log of n. So this happens when you have a for loop at this, like either as the parent, let's say, like that's not nested, or inside nested. It doesn't really matter. But there's also a while loop that's cutting which values it's using by a certain amount. So you just multiply those because we know that the while loops have log n and the for loops have an n. So just multiply for nested loops, essentially. So we can go on to an example of big O. We're going to be analyzing this intersection function. And fun fact, this is a very similar problem to what you're going to be getting on your midterm. So here we have an intersection function for the set. I'm sure you guys are familiar with this. I think you went over it in lab or lecture. So here we're just setting the target as a set object, and then we're running a for loop and an if statement, and then we're just using an add function to add the value to the back of the target, and we're returning the target. So really quickly, constructor functions are always constant. So all variable definitions, for that matter, are always constant. So with big O, if nothing is nested, we don't really have to pay attention for it. We only look at the highest efficiency. I mean, highest efficiency in terms of the n, because that means so big O is the worst case scenario. So we're always looking for the least efficient part of the function unless it's nested. So next we have the for loop, which is O of n. All for loops are linear, like we talked about before. And so this if statement is a funny case because when you're looking at if value in source is a list, and if we're looking if value in source. So we have to look at every single value in source to determine if value itself is inside of source. So this even though it's an if statement and it kind of seems like it should be constant, it's actually linear because it's looking through the list. So that's where a lot of students get confused. Even though it's an if statement, it can still have the same time complexity as a loop because it's looking through all the sources in a list, all the values in a list, sorry. So nested linear statements, like we talked about before, mean this function has a time complexity of O(n) times big O of n, which means it's big O of n squared. So that's what the time complexity of intersection is.
Sweet. So let's jump into some recursion now. So we're going to look at recursion, what it is, how does it work, and what are its applications. It's probably one of the most complicated, I guess, concepts that we're covering. Next to Big O, I think these are the two big ones. So what is recursion? Recursion, at its most basic, means defining something in terms of itself. So that might be a little bit confusing, but we'll get into that. Recursive algorithms have two main parts. The first being the base case, where the recursion does not take place, and then the recursive case, where the function is called on a different value than previously given. So the base case will always be the thing that will kick you out of the recursion. It's usually the last thing to happen. And the recursive cases are the meat and potatoes of the recursion as you feed new data into itself, essentially recursively. That's where the word recursion comes from. So over and over again you're calling the function within itself. We'll see that here, and you can sort of see it with our image on the side. So here's some common use cases. So functions that need to call a previous result of the function as a part of the result's definition. So to break that down a little bit is, let's say you needed to call a function on itself in order to continue doing like a process in order to get your final result. So a great example of this is the Fibonacci sequence, because it needs to add the last two numbers in the sequence to create a current number. So if you need to know the last two things, or the last two items, or last two numbers in this case, you need to use recursion in order to be able to add those two numbers together and then call a function again to get the new number. Uh, it's very difficult to explain through words. So let's look at a quick example here of what I mean. Yes, this will be posted later, but first the people asking in chat. So here we can see the Fibonacci function here. This is our recursive function. So we have if n equals 1 or n equals 2, this is our base case. We have a result equals 1. And notice that when we say result equals 1, the reason that this is our base case is because we're not calling upon the function again. We're not calling back on ourself. And when I say ourself, I'm talking about the function that we're currently inside of, which is our Fibonacci. So then we have our second case, our else case. And this is a recursive case. And the reason it's a recursive case, as we can see, is because we're calling upon ourselves upon the same function again, just with altering our inputs, our parameters. So we can see that we take our result is now going to be equal to the Fibonacci number of n minus 1 plus Fibonacci of n minus 2. So taking that from our n that was inputted originally, we can see that we're now altering that parameter and doing a calculation on each side to return the result. Now, note that calling these two functions again will not reach this return statement until the very last base case, I believe. Correct me if I'm wrong, Stephen.
No, yeah, that's right. So
Okay.
this Fibonacci sequence you're calculating. So the n is the number, like which number in the Fibonacci sequence you want to calculate. So if you give it 10, for example, so the first two numbers in the Fibonacci sequence are 1 and 1. That's just how it starts, and then it goes 2, 5, whatever, whatnot, and yeah. So it doesn't get to the base case unless the n value gets to 1 or 2, and then it results 1. So
Right.
yeah. All right, so we have one more example for recursion. It's kind of abstract, so like Rob, if you want to let me do it, because
Yeah,
it's
sure.
not really self-explanatory. Okay, so imagine you want to have like lunch with your friends, but each of you only has each other's number. So Obi only has Safe's number, and Safe only has Rob's number. So each has to call the next until they can relay the information backwards using recursion. So our base case in this example is if our list passed to the function, so this is our list of our lunch guests, so Obi, Safe, and Robert. If it's empty, the lunchtime equals 1 p.m. So when we get to the end of the list, when everybody has been called, we understand that the lunchtime that we want is 1 p.m. Else, lunchtime, so this is our recursive case, lunchtime equals phone call of list indexed at so everything after the first index. So we're just removing the first index from it. So just a quick run through of this. So we start off calling phone call of Obi, Safe, and Robert. So Obi talks to Safe, and so Robert's the one that is really the master of all this. He knows when everybody's schedule is. He knows when the perfect lunchtime is. But Obi doesn't have Robert's phone number. So Obi has to call Safe, and Safe has to call Robert, and then Robert has to go back and whatever. So for Obi to get this information, he has to call Safe. So that's the phone. That's the first phone call function. And since the list isn't empty, the lunchtime equals phone call of just Safe and Robert. So then Safe uses the phone call function on the list Safe and Robert, and the list still isn't empty. So the lunchtime equals phone call of just Robert. And so, actually, sorry, this shouldn't be is empty. It should just be length of 1 because Robert's the last person, but it doesn't matter. It's the same concept regardless. So Robert then tells everybody that the lunchtime is at 1 p.m. and he sends that information back using recursion in this function, and everybody knows to meet up at 1 o'clock. And they all have a beautiful lunch, and everything's perfect because we use recursion. So yeah, that's just a little
Yeah.
real world example for you guys.
Yeah. So does anyone have any questions regarding anything that we've covered? Because we're now at the end. If I were to guess, you probably have questions about recursion because it's probably the hardest thing. Like, yeah, and we got a ton of. We breezed. We flew through the content. Like,
Yeah, guys, don't be afraid to ask any questions you have.
yeah,
We're
ask any
always
questions.
free to answer them. Somebody asked any recommendations for the midterm. Yeah, so I took the midterm not too long ago. I think the main thing is because I think you guys were told you're gonna have like a little quiz about Big O and just how to analyze functions and stuff. So just go over all of the examples that you guys were given on how to analyze Big O, and just like look at other functions that you can analyze that like the Big O time complexity of, like look up maybe practice problems online, but definitely focus on Big O if you're struggling with that. And other than that, I just say any more recommendations. I think you should probably practice creating data structures and just making sure you know the syntax properly. Other than that, I just say any more recommendations. I think you should probably
Obi,
practice creating data structures
Obi,
and just making sure you know the
Obi, you're hot
syntax
micing.
properly.
Obi.
I just say any more recommendations.
My bad. My bad. Sorry. I was trying to hop on and it was kind of messing up. You guys already answered that question, right? Midterm advice?
Yeah. So they said
Sweet.
for the midterms, I'll have something we don't know yet. That's going to be a big old mystery. Also, I hear myself twice, Obi.
Are you sure about that?
I
Because
could,
I'm not seeing anything else.
I could.
Let me mute and see if that.
Okay, thanks. Anyways, yeah. So it's gonna be something that you don't know yet. That's very vague.
Oh, okay. So I think this is something that
Like,
you guys don't know yet is just going to be a data structure that isn't like exactly to what you learned in class. So you guys learned like what's it called? Lists, queues, stacks, whatnot. But you're gonna have to probably implement another data structure that's very similar to those ones, but just like the functions are a little bit tweaked. So that's why I'm saying
okay.
understand like the syntax and stuff and just know how the methods are actually being implemented. It'll really help you guys.
Yeah. Okay. Yeah, that's a
Pretty
good
much,
point.
yeah. Yeah, I would recommend. I mean, I dropped out when they were talking about their parts, but unless they said it, yeah, you'll tell me. But I think you guys should focus on actually building out the classes and then testing out like example scenarios in real life. So I would recommend this. Go basically get the right code you need and figure out the code you need to build the classes to begin with. Understand it, but then start actually trying to like implement some kind of example for yourself using like a stack. Um, if you saw the way we kind of laid out the Replit example, we kind of just put it into one simple example where it's like you kind of go step by step through using some different features. I would recommend doing that.
Right on.
Guys, if you don't know, by the way, this is Obi. He's our VP of operations. So
Of
he just
dev. He's
really,
VP
really
of
knows his
dev.
stuff. VP of dev. Sorry. My bad.
All the same.
Yeah. VP of dev. So he really knows his stuff. You guys should listen to him.
Do we have any other slides that I should be looking at here? Oh, thank you for coming, slide.
Yeah, we'll just no, go back. We'll keep questions for a little bit, and we will.
Just making
Yeah,
sure there's nothing
we'll
else.
keep it open for everybody because questions we can have a lot of time for people to come up with some. And if you have any parts that you want re-explained, we can go and review them if you want. So just ask in the chat.
Oh yeah, and also be sure to leave us some feedback. Open up the link there in the chat and give us some feedback if you guys have any suggestions for how we should do these in the future. Yeah, so if anyone has any questions in the chat, can you send the Laurier experience from form? I assume.
Do you want to just put it to the
Yeah,
first slide, I think?
but you're
So they
muted
can
by
see
the way
it.
if you're talking. I don't know if Obi, you're muted. You're muted, Obi.
I swear this happens. This happens too much, man. Anyway, we said we we messaged in the chat twice about it, and you might have not been here. It's just totally understandable. But if you don't have the link, we'll just go back right now. Actually, Rob, can you go back? But we posted it twice in the chat. So if you do have access to the chat history, it's in there. Like a link to actually look at the PowerPoint yourself and view it. So you should be good.
Is the link at the beginning?
Let me find the link and I'll send it one more time.
Let's see. Oh, this was the sign in. There you go.
Perfect. So anybody who is wondering if you could get access to these slides, this is the easiest and quickest way. I'm not sure if we'll post this link itself later. We might also let you know maybe in Discord, But right now, I would just take this link and save it because this is the actual presentation. You can go and review it as many times as you need to.
Wait, which link are you referring to? The one on screen is the sign-in link. Are you?
I sent a link in the chat.
Oh, okay,
My bad.
perfect. Yeah.
Sorry, I should have clarified the Canva link.
Yeah, the Canva link will give you the presentation. The Typeform link will send you to the sign-in.
Mm-hmm.
I was wondering how much practice we should do for this midterm. Honestly, I'd say it's
First,
a very
before we answer,
subjective
Rob,
thing. Yeah.
when is the midterm again? I'm bad with times and dates. When's your midterm, guys?
February 17th, no?
17th?
So next
Yeah.
week.
Okay. Rob, you want to answer?
Yeah, I can answer. Honestly,
Oh, 14th, sorry.
the 14th. Okay, so it's closer.
My bad. Yeah.
Definitely just do a little bit of like a self-evaluation of yourself and just really like be real with like where you're at, and let's say like go back throughout like labs and assignments you've done, and if there's any that you struggled with, or let's say you had to get help with, kind of like start there and try and tighten up those, like, I guess, loose links first. So let's say you had problems with like stacks or something, just definitely try and just button down those anything that you just have a little bit of trouble or wavering I guess knowledge with first. And depending on how much that is, it could be a lot or it could be a little, and from there just I would continuously review and do problems.
Yeah. To add on to what Robert's saying, this is something I highly recommend because this is something I do during exam seasons that gets me actually in shape to like do questions and like make progress in them. But I haven't actually been doing it lately. You should basically outline your full day for blocks of time. Like make sure you obviously have your lectures or whatever. You already know when that is, but go block by block, separate your hours by like 15 minutes and say like work X amount of time on this like part of coding that you're weak on. And then basically fill up your day like that because you're probably gonna miss a couple, although don't try to. Now, the reason it's like work X amount of time on it is that there's a difference between something that's called input time management and like output time management or something like that. When you try to, most of us try to focus on getting something done when we sit down to do it. Like we say, like basically work on and finish or work on um, like homework, right? But a lot of the time you won't finish it. So just say work on it X amount of time instead, and then just come back to it. It's a better way to do it. So, and
Yeah,
honestly, it's not that bad.
somebody asked in the chat, is there any other data structures we should research so we are more prepared for the new one we learned in the midterm? I don't know if new data structures, like really, I think you should just review the ones that you've learned in class because
They're gonna be a
the one
modification.
on the midterm isn't going to be like
Yeah.
far off from what you've learned in class. It's not going to be like
Yeah.
anything extremely foreign. It's
I
going to be
think
very similar.
usually, I think in the past it's been like an alteration to one of the ones that you've had learned. So be
Yeah.
prepared for like a slight
Yeah.
like tweak in, like, let's say like a Q or something like that.
Yeah.
The requirements will be given to you in the question. Like, he'll clearly explain what the difference is. So so long
Yeah.
as you're familiar with, like, the data structures, and you're very familiar and comfortable with using them and whatnot, you should be able to adapt to it.
Yeah. So on that note, first of all, yeah, it does say if your email says that, then that's good. It means you have one less thing to study for because we didn't even go into like that much detail on it. Recursion is notoriously difficult to explain, but once you get it, it makes sense. Now, as someone else was asking, can we talk about circular queue? It's not something that you need to learn right now, but we can do it. I can briefly talk about it. I don't remember every detail about it, but from what I remember, it's a pretty simple structure. So basically, you just have a list, aka the queue, right? And then things get added into it. But then once you get to the end of the list and you add more stuff into it, I think you add new stuff into the beginning and push everything forward. Something very close to that. And then the thing that gets pushed forward either comes out or the list gets bigger. I think the list just gets bigger. So it has a way to point back to the beginning, something like that. But you guys don't need to learn it right now. I would watch YouTube.
Yeah, the circular queue isn't. That I'm sure that's what you're talking about. Yeah.
Yeah.
Yeah, it's not. It's not like that heavy of a topic on the midterm. So
It was
yeah,
in we need to learn
yeah,
it.
no,
It was
it's
in our assignment.
like other than that. Somebody said, can we go back to the intersection big O example? Actually, wait, hold on. So the target equals set was just initializing a set object. So actually, that would be a very good example if you guys haven't learned about sets in class to try and implement a set on your own. So a set is like just a list. You could even do a set that's a queue or a stack where each item inside of the object is like unique. So to
Yeah.
this,
So to add to what you're saying before you continue, you should use the set the set built-in data structure. There's a built-in one in Python, but you basically enclose it in a class. So I
yeah,
go on to us.
exactly. No, but yeah, to answer Miss Mia Wallace's question, we were just like making an object that was a set, and we just like it was more about the actual big O analysis rather than what the function did itself. So
So one
How about
wants
we actually go check out the slide really quick?
yeah, for sure.
what slide?
No problem. I think it's somewhere. It's probably around slide 40 or 30, between that range, I think.
The
Try
slide
to
for
get
what
over.
exactly? Sorry.
But, let me find it for you. Let me find it. Stacks, queues. There we go. It was it's related to, was it stacks? I can't remember what was the example
Uh,
for the topic.
the set one
Yeah, the set
that
one.
was all the way at in big O.
Oh, that was big O. My bad.
Yeah.
Okay, I see. I see. Okay, cool.
So we're just like analyzing what the
Oh, I see.
yeah.
So let me look at it. Okay, so all it's basically doing is going through. So what this is doing, the example itself. Well, first of all, the point of this example was to
Obi, what slide is
show
it?
it's slide 49.
Okay.
So the purpose of this example wasn't to show like how to do intersection of like two different items. That's not like the purpose, but that's the example that's being used. So all this is doing is just showing you that there's some this is a method inside of some class, right? And when it says for a value in self, it's referring to, I'm guessing, just a list that is already stored in the class that's like representing the thing. And so what the target is, it's not a specific number. It's more like maybe, I guess, target results or something is better, because all we want to do is loop through the items and the list of our class and check if the values check if the values in that list are also in the other source list that got passed into the function. I know I kind of butchered that explanation, but basically it's checking if our list
Good.
has any of the items match the
Share.
other list,
Yeah.
and then it's going to add them to the target and then
Yeah.
return that target to you.
Yeah.
So the purpose of the set, like in the example itself, was just to just double down on the fact that your target doesn't want any duplicate values. So like a set is just like pretty much a list without duplicate values. So that's what I'm saying.
So someone said, can you just go over how we make test modules for stacks queues, a sorted list?
Okay. Can you clarify what you mean by test modules? I
Like
gotta
unit testing?
I can like I can infer from what you're saying, like what you're getting at, but like, can you be a little bit more clear? Like ways to actually test out stacks and queues and stuff. Is that what you're asking? Like how to set up like a file, kind of. Okay. Okay. Okay, so first of all, it'll be testing methods for um, the data structure. So in Python, it's a little bit ambiguous. So if it was say like Java, um, there's a clear distinction between like a class and an abstract data type. Like there's like the difference because abstract data type is actually a type that's forced by like the language, which is Java. In Python, they're just both represented by classes, and it really just depends on which one you know is a data type, like an abstract data type, and which one is a class. But anyway, basically the way you should test it is do this, okay? If you guys know how, or you have to figure it out if you don't know how. Make a class, and if you want to have the class in its own file and import it, you can deal with that. But you can have a class in the same file as your test stuff. So make a class, and then literally just below the class and the script start putting some dummy data, and then like start maybe use a for loop to add that dummy data into like a stack object that you made. Like basically, say I have a stack. I basically go down. I want to test adding some stuff to the stack. I'll make a little list of some values I want to add, just some test values, and then I'll make a for loop. Well, before that, I'll make a variable called stack or something, and set it equal to the stack class, and that'll give me a new stack object. And so from there, I can use a for loop and use the one of the methods inside and say on each loop, add each item of the list into the stack. It's going to keep adding stuff, and that's like one way to test like pushing to the stack. So that's one way to do it. Um, I don't really know. That's just like the general way you kind of approach testing like things you make, I guess. Um, if you really want to see if it works, you have to use practice stuff. What's up, Steven?
So another thing that Obi didn't mention is make sure you can test it on multiple types. So don't just put numbers in it, try to put strings as well. And if you have like any objects, like I know you guys have been working with like the student or food classes, either one of them, try to put those objects in your like array-based like stack or queue or list or whatever, just to make sure that it works for all types of values.
Or more specifically, like you're right, but more specifically, try different test cases with different sets of data that's like the same type.
Yeah.
Because it's better to test like all integers at once and then all strings at once because it's kind of bad practice once you get into coding and you get better and you have more complex stuff to use multiple types. Even though Python lets you do it, it's just because Python's like it's like the most flexible language. You can do triple backhand spring if it wants. You know what I mean?
Yeah.
So yeah. How we return. So you basically mean just how we return the functions. Okay. You don't. Let me actually try and pull up. Let me pull up. Give me a second. I'll see if I can actually pull up an example for you and actually do it.
You can use the ones on Replit if you want. I can share my screen. Like we
Yeah,
can
I'm
just go through.
gonna use one of those. I'm
Yeah.
actually gonna go use the stack one right now.
Yeah.
All right. So, are you sharing the stack screen right now?
Am I? No, I'm not. I can do that.
Yeah, one of you guys. Now I'm gonna make this example simpler by I'm just gonna duplicate this and open up main2.py for me, bro. 1 second. Do you see it now?
Yeah.
All right,
Gotcha.
cool.
Also make the code like larger if you can.
Yeah, I'll
Like,
make
zoom
it
in.
larger. He should make it, yeah. All right. So I'm gonna modify this a little bit. I'm gonna get rid of restaurant. I'm just gonna remove all this, okay? So what I'm gonna do is say this. Let's say I had a plate of dishes. I mean, a stack of dishes, okay? Like the restaurant, just to make it even simpler.
So just to add on, you said returning a function is easy, but when it comes to different array types, it can get confusing.
Can you clarify what is?
Different
Let me just,
array
before I go on with this
types.
example, I want to get what your question is right, so I don't waste your time. Are you asking how to use the methods that are attached to the data structures, or how to return certain items in the functions. Like, okay, I'm gonna keep explaining really quick. I'm just gonna show you. I'm gonna make a variable called stack of dishes. I'm gonna give it the class of stack, right? So I'm gonna say stack. I'm not gonna pass in any values. Actually, I'll probably do myself a favor if I add in some dummy values right here. Let me actually do it up here. So I'll say plates, okay? I'll make it a list of maybe some different types of plates, okay? So big plate, small plate, big, let's go big, small, rectangular.
You said how to use the methods and return.
Yeah, I'm gonna show you right now.
Yeah.
I'm gonna show you right now. So we have these three types of plates, right? We just have, let me say plate one, small plate two. Like, you guys get the point. These are plates that are dirty and we have to clean them. Okay. I'm gonna pass this list in here into this stack
So watch
object.
out. Oh, but you can't do that just because you're gonna have to do it with the push method.
Oh yeah. My bad. I gotta push all of them. I forgot you can't just initialize it like
Yeah.
that. Anyway, now we have our stack object. Okay. I'm gonna go and push all of these new plates onto the stack so that our server can start taking them off the stack and then start washing them. So I'm gonna go make a for loop. I'm gonna say for plate and plates, and then I'm gonna say this. Okay, I'm gonna say stack of dishes dot push, because that is a method of the class, and this variable stack of dishes is an object of the class, which means it has this method that we can use on it. So I'm gonna say stack of dishes dot push plate. All right, and when I run this, I'll show you the output on each push. So I'm gonna say print stack of dishes, and then it should be dot values, dot underscore values. So basically show us the list of dishes. All right, Steven, can you run that and tell me if it?
Yeah. There we go.
All right, so there you go. You see the front. In fact, I'm gonna make another. I'm just gonna say back and front, just to make it very clear which is the front and back. Okay, Steven, can you run that one more time?
Yep.
See, so the back of the key of the stack, or the bottom of the stack. It's usually top and bottom when it comes to stacks, because it's like stack, it's on top of each other. But that's how you use like a method. Now, say I wanted to get those values, right? I could just do this. I could just do print stack of dishes dot, or actually just, if I just wanted to save those values, I'll just say dishes equals stack of dishes dot underscore values. And I don't need to pass any parameters into this call, because it's just asking for like an attribute that's a class attribute. So
One thing though is that do note that the underscore um in Python signals it as kind of like a private attribute or method. So
yeah,
doing that, so like don't do that in questions if you're writing an answer to something. If you want to quickly test something or whatever, like you could pull the values out of the stack like that, but just know that using like the underscore values and just pulling the whole list or manipulating the stack without using its interface or its functions like push pop and peek is like technically incorrect, so just keep that in
So
mind.
here, just so we can do both, we can literally just make another function right here called view values, and this will like solve both OB and
True.
oh, okay, yeah. So what Steven just did right there with deep copy, it's nothing complex. It's just so that basically if we ran this function and didn't use deep copy, the person who got the return output from that function has direct access to each of those values, which means like he can actually edit the object's values itself. Like, you don't want that to happen unless that's intentional. Sometimes you just want to see the stuff or give people their own version of it, so they can go do their own stuff with it. You know, you might have a database. You don't want them to be able to touch and mess up your stuff that's saved. You kind of get what I'm saying there. But that's a good function. Let's just show the push function. Okay, I'm gonna say stack of dishes dot push, and I'm gonna give it. I'm gonna say I'm gonna give it a bowl. Say push a bowl to the stack. All right. Now I'm gonna print the stack of dishes at the end. Comment that out. Print stack of dishes and show us what happens. Oh wait, my bad. Actually, yeah, that should work.
Yep, there we go.
There you go. So now stack of dishes has been added. It has a bowl now, and then you can keep doing these different methods and passing stuff in. And the thing about every method, even if you don't have any parameters to pass it, if it's a class method, it needs to self. You guys, I think, know this by now. You need the self. Technically, is a parameter. So yeah, self parameter, so that it can access its owns its own attributes, access the attributes that belong to self, which is the class.
Yeah, and so just like that's the reason we put the dots after the variable name, because when we put the dot, we're like accessing
An attribute.
like the object's internals, so
Yeah.
so to speak. But yeah.
So I see someone is asking, are dishes right now a stack or a list? Oh, you already said change the variables or something. Yeah. So like we already talked about, these are a lot of these data structures are made using basic stuff like lists. It's just a twist on it. You know what I mean? Rob, do you want to talk about it a little bit?
Yeah, so these are what's known as like array-based implementations of data structures. So at the core of each one of this stack or queues, you find a list in your implementation. So that's kind of what we touched on earlier a little bit, of like list being kind of like the root of these two data structures right now. So yeah, they are essentially lists, but we're kind of changing them up to act a little bit differently, essentially, through each class. And later on in the course, you'll see the lists go away, and you'll see what's known as the linked structures come in. So yeah.
Sorry, my bad. It's a bit weird that we're using. Okay,
That
I'm gonna explain the real reason we use a data structure to do the same thing that a built-in data structure does. Okay, the reason we use a class to do this stuff, aka a data structure, is to hide some of the information from the user. If we just use a specific, like just say we used one list, like a regular list. Say we wanted to just let someone see all the stuff in the list, but we didn't want them to be able to actually modify it or like maybe do something else with it, you know? We can't really do that if we just have a normal list, you know what I mean? We have to the only thing you could do with the list is send it to them, and then they can use like the normal built-in methods on it. But if we use a class, we can do some other things with it. We can be like, okay, actually, stack is the best example. If we use a class like a stack, we can basically force them to only use a few methods on it. Like they can only use the ones we define. So they can only push stuff to it, take stuff out of it, and like peek at what's inside. But they can only touch basically what's at the top of the stack, is the bottom line. And then they can't mess with the stuff that's further in. And that means that the data stays more like secure in a way, and also like, yeah, it's pretty straightforward like that way. So I hope that was a decent explanation for why.
Yeah.
It's basically to enclose something, because like if you had an engine and like a basic car frame, you could give it to somebody, but like they might mess up some other stuff inside of it that's like exposed, you know? So you wrap it in like the front, you give it like a body, a shell, you know, that kind of stuff.
Yeah.
And then they, you know, you want to explain, Rob?
No, you hit it on the head there.
Perfect.
Someone said, are we allowed to use private methods to test? I would do exactly what Steven did and make a public function that calls on your private values.
Let's just change it here instead, just so we're consistent with what we're saying.
Yeah. So
yeah,
it's just
Yeah.
bad practice to be using private like functions and variables outside of the class. So just for best practice, just avoid doing that.
yeah. Somebody asked, is there a general format for the general methods of each array method? I wouldn't say there's like a general format, but I think there's kind of a general like logic. Like for all of the ones, actually, maybe there is a general format.
There kind of isn't. I mean, you're saying each array method. By that, I'm guessing you mean just each class method.
Yeah, I'm just like each array-based class has the same.
There's no format. It's just there's some basic ones that each stack you're gonna have. Like a stack needs to have three main functions, right? You need push, pop, and peek. They pretty much all run like have the exact same code. So that's like the format for those, I guess. But if you had some other functions, like you wanted to like modify that code, maybe it's like multiply all items in the stack as a function, a method in the class. Then you could do that and just code it out however you want and return whatever values you want. You can also, you don't have to, but you could return whatever you want. It's just like, it's a custom function that only you can do only on that objects of that class. Does that make sense?
So just one more thing to add, just for like the insert functions themselves, there's like some other array-based things where like insert kind of is like varied. Let's say for a set, for example, it won't insert anything unless it's unique in the list, like that it's being inserted in. So like the logic that you're using to insert is still going to be append, but like you're going to be adding more stuff onto it. So I'd say it's not really a format that's consistent throughout, but I think the logic, like if you understand the push and pop methods, you can add the little tweaks that come with the other array-based methods like very easily.
Mm-hmm.
Yeah.
Yeah.
Yeah, and someone's asking, will the autograder be affected by us adding another method?
I mean, as long as you're executing the right method that it's asking for
Yeah.
and the auto grader is getting the right output, regardless of whatever you do to it before that point, it should be okay. Like
Yeah.
Yeah.
the auto grader is gonna run the method that it's like
Looking
it's
for.
been programmed to run. Like it has a preset value. Like I'm gonna run the push method, and it's expecting to find a push method. But say you for some reason wanted to run some other operation before that point, and then like return it back to the same way it was before. Like I don't know why you do that. You know that would be it should work as long as the auto grader gets what it was expecting. That's the answer.
Yeah, like so I guess so long as you're writing the code to answer whatever the question is, and if you do anything additional to that, then it won't really be graded. So I guess you
Yeah.
could do whatever you want.
Yeah.
Just so long as the core question's okay.
Yeah. If it compiles, it should be fine.
Yeah, and if it compiles.
Yeah.
Yeah, that auto grader is kind of annoying for me at times. I mean, it still is, you know. We'll be just on data structures. So you're not gonna have anything on more advanced queues. Nothing like that. So can you pull up the Fibonacci example? Actually, Rob, if I share my screen, like they'll be able to see, right?
Yeah. Let me stop. Actually, should I just pull it up?
I'll pull it up so I can walk through real quick.
Yeah, for sure. Let me
Also,
unshare mine.
yeah. But also
Yeah.
do note that the recursion stuff is not on their midterm apparently.
Yeah. So I'm gonna share my screen with you.
Yeah.
I'm gonna try and explain this as best as I can. Okay. It'll be better. Like I have a whiteboard, but I can't really fully show you like that. But anyway, let's go like this. Okay. You can see my screen. Which screen can you see? Oh shit.
The slides.
Is it my Discord or
Yeah.
No, we'll see.
No, the slides.
You're,
you seeing the slides? Okay, cool.
this is not the right slide.
Yeah, I know it's not the right slide. Okay, so it was Fibonacci right here, right?
Yeah.
And so the person asked, wouldn't it always return result 1 or something, right?
Yep.
All right, so let's walk through this. Okay. I'm gonna make a quick file really quick.
So someone's saying circular queue, sorted list, priority queue.
We'll deal with that question in 2 secs. Is this short answer or do you want to talk about it?
No, just continue what you do. I'm kind of just filling here.
Okay. So Fibonacci, okay? The reason why you won't, unless you pass it the value 1 or 2, the reason why it won't just return 1 on the first time is because of this line right here. So look, if you look at it, I don't know if you can see it. I'm zooming in now.
Yeah.
Say I passed it the number 5. I want to get the Fibonacci sequence for 5. I think the answer for that is like, I don't even know. I'm not a math wizard. But anyway, if we look at this, if I give it 5, I mean, clearly by this if statement, it's the first if statement it encounters. 5 is not equal to 1 or 2. So we're not going to encounter this like execution on the first run, you know what I mean? So now that we're not going into this pathway, we're going to go into else. And so once we get into else, here's what happens. I mentioned in the chat, this is kind of like Gremlins. I don't know if you've seen Gremlins, but literally like little monsters, and they keep multiplying like crazy, right? And then they keep being like they get exponentially more destructive, basically, and they all can do the same things too at the same time. That's kind of how recursion works. Like you basically split, and then they start doing the same thing at the same time. Split, anyway. So now that we have just passed and skipped past this first part, we're gonna go into the function again, but we're just gonna pass it the value -1. Basically, just decreasing the value we're passing into the function that we got to start with. And so on the next run for this specific function, it's gonna get 4, right? And then once it's goes through this again, 4 is not equal to 1 or 2. It does that same thing over and over until you get to 2. I think it's 2 we should probably get. That'll happen. Once we get 2, so basically we have 3 minus 1 will give us 2. We're going to go into this part of the if statement, and then it's going to return 1. But here's the magic of it, okay? Since we're returning 1, what happens when this finished executing, right? The value of this becomes 1, like 1 itself, and it's like 1 plus the next other recursive call. And so once you go back another level, you get basically 1 plus 2, or 1 plus 1, 1 plus 2, and some other like combination. Fibonacci is a little bit weird to explain verbally. It's one of those things you have to practice or just like do it. I'm telling you, we're trying. It's not.
You need to draw it out as a
You have to
tree.
draw it out.
Yeah, I actually drew it out while you were talking just because I
Okay,
was bored.
Perfect.
But like, I kind of like if you guys want to like visualize it, you can visualize it as a tree. I don't know like how well. I'm sorry, it's so ghetto. Okay, whatever. Let me just like explain what I'm saying first, just so like, you guys understand. So let's start off at the like imagine it as a tree. So your 5 starts off as like the top node at the top, right? So because it's not equal to 1 or 2, which is our base case, it doesn't return a result of 1. So our 5 still doesn't have a result. So because of that, we go to our recursive case, our else. So the Fibonacci n-1 branches off to the right, and the Fibonacci n-2 branches off to the left. So now we have 2 nodes here, one of them equal to 4, and the other equal to 3. Yet none of them are equal to 1 or 2, so we have to keep going with our recursion. So our 3 node splits up to a 1 and then to a 2. And then our 4 node splits up into a 3 and then into a 2. So now we have the four nodes left. One of them is a 1 and a 2 over here. And so these we know that the Fibonacci of 1 and the Fibonacci of 2, because of our base case, are 1 and 1. So keep in mind that these 2 nodes over here are 1 and 1. And then we have a 3 over here, I believe, and a 2 as well. So the 2 we already know is equal to 1, and then the 3 is equal to 2 and 1. So we add those together. It's a 2 here, a 1 beside it, and then the 2 here, I think. And then we add these 2, and it goes up, and then we go up again, and then we get to the 5. So you're going down the tree, and then the recursion, after everything's done, you come back up from the tree. So if you guys can visualize it like that. So the Fibonacci of 5 would result in 5 because you're adding you're just adding the ones from the bottom node together.
Yeah.
It just builds all the way up.
Let me just. You were trying to draw a tree, and I have a whiteboard, so I'll just show you. Okay. In fact, can you quickly calculate the number so I could just make sure the math is right?
Yeah,
All right.
it's 5. It's 5.
So what's going to happen is this. So 1 minus 1 is 0, and then there's nothing else to add it to. Okay, so like NA. All right. You guys should be able to see. Oh, it's blurred screen. Okay, let me just really quickly tell you. The better example to practice is, know how to do this code, but to learn recursion, practice factorial, because factorial is a lot simpler in terms of like understanding. It's just a simple like this multiplies by the one below, multiplies by the one below. It's very straightforward. Anyway,
Someone's saying in chat we're all less stressed about recursion since it's not on the midterm. We didn't have the
that's facts. That's
machine
facts.
testing on oh sorry, we didn't have machine testing on
Mhm.
circular Q, the assignment. In the lecture, D Brown kinda implied that it might
That
show
circular
up.
cube is gonna show up.
Yeah.
Interesting.
Previously, it
Interesting.
hasn't. That's all.
That triangle is
Because
like a
I don't.
binary tree. Yeah, that
As far as we, yeah,
it
as far as
wasn't
we've come across, we didn't know or haven't seen anything in your notes or lab notes or assignments that we didn't fully check assignments actually, but labs we didn't see any of circular Q, so we didn't really go off that. I'm gonna show you really split second, and then we'll like skip this because I know this is like you have better questions or better things you'd want us to review. But all right, let me unblur. All right, so we have a number, right? We pass this number into the Fibonacci function. So what it does this. So because 5 is not 1 or 2, which is the base case, and you'll understand why once you do it. We basically run the function, which is like Fibonacci n minus 1, and the value we pass into it is 4 because that's 5 minus 1. And then on the other side of it, we pass in the value n minus 2, which is 3. So we basically do that multiple times until we get to the bottom. Now I'm going to explain what happens at the bottom. At the bottom, we get this final recursive call. Okay, this is actually a better side to look at. Actually, this side. So once we get to this final call, this basically since n is equal to
it's base case.
n is equal to 1, we are going to return 1 in that function. So
You're hitting the base case.
yeah, basically at the base case. So once we go back up a step, things ran out. It'll basically add. So each of these represents a recursive call. Like you basically ran that function on each of these spots, and then in between them, once you get to the base case, that's when the result, which is 1, starts getting added to each other. So this is like Fibonacci n minus 1. This is Fibonacci n minus 2, and then the results from those, which is both 1 at the end of the day, gets added, and then the same thing goes for this. These two get added, so that's 1. That gets added, and then this has some more, and it keeps adding, and so we'll go back up again and add the results from those two, and it keeps adding until it accumulates all the way back up to the top. All right, enough of that because it still is like not really easy.
It's also not on your midterm.
Not a midterm. Yeah, so forget that. Let's actually go back to something else.
Like what? Like circular Q or something? Or
Let you guys have any other stuff? We could go over a couple things, but some more direction would be helpful. Circular Q, I'll pull up something and look at it. Let's go over it real quick, since you guys keep asking. Circular Q. So for this, go find the code and learn it yourself because we didn't fully prepare for you. So sorry about that. If it does show up on your midterm and we didn't cover it. So it says linear Q is based on like the Q principle, first in is the first out. The last position is connected to the first position to make it a circle, right? So let's watch a video actually. There's no 2-minute videos on it. So no, let's
if you
not
just
do
pull
that.
up an image,
Let's
it
do an
should be
image.
enough to explain it.
Yeah. Sometimes images are bad to understand too, but we'll try it. All right, so let's try looking at. This is a bad example to look at. Okay, let me just say one thing. I don't think we should go on with this because that'll only make it confusing. I don't want to do that to you. What I will say is the fact he said it might show up on your midterm means it might show up in some small capacity, maybe as a bonus question or even a real question. But go and like learn that so that you know like you don't have to worry if it comes up. Just do that for yourself because we're clearly struggling with this part of things.
I mean, we could. I mean, it's not that hard to explain a circular cube.
It's not hard to explain, but the details, like I don't want to mess it up fully.
Right.
The main idea is this: you add stuff into the queue, and as the queue gets full, once it gets to like full, the item at the end of the queue, I think, replaces the item that was added to the front of the queue. Something very close to that, or like as it gets full, um, yeah. So it's like this. Say I have 1, 2, 3, 4, 5. Say I wanted to add 6 into it. So I'm gonna add 6 into the array, and then it's basically gonna push it, and it's gonna take 1 and throw 1 behind 6. So it's like just getting more full. So it's not eliminating anything. So now we have 6, but instead of like 1 being at the front, the quote unquote front, or back, I can't remember, just the back, it's actually next to 6 now. That's how a circular queue works. Basically, I add 6 at the end. It basically keeps all the values, but just take this one, puts it behind the 6. That's what
I don't know
I
if you can see
like.
the stream. I found an image that might help.
Yeah, that'll be helpful. I can't really see. There's like not tons of.
So, just like I'm just looking at the visualization that you guys have in your lab. I think it explains it really well. So as you insert into the circular queue, the rear moves through the circle because you want to. So you're always inserting at the rear, but the rear keeps moving forward because you want to fill up the circle, like at the end of the day.
The rear moves back to the front. Back to the front. Is that what it is?
Yeah, the
It's
rear
that.
starts from 0 until it gets to none when the thing is full.
Yeah.
And then as you remove, you're always removing from the front. So the front, when it's full, when the queue is full, is at 0. And as you remove, the rear goes back to 0, and then the front goes from 0 to 1, 1 to 2. It just goes around
Yeah.
as you remove.
So I think it works like this. Okay, I have 1, 2, 3, 4, 5. I want to add 6. I want to add 6 into it, right?
Yeah.
So what I do is I add 6 here, but because I want to like make it circular, I just basically take the 1 and put it there. It could be the opposite way, but that's like the idea.
No, you don't move any values. You don't move any values.
Does it replace the 1?
No, it doesn't.
It's
Okay,
the
well,
index
it
position,
depends.
isn't it? Or
It replaces the position that's at 1, right? Or something.
Oh, that's
Okay, I
don't
think
move,
it's like
you
this.
don't move the
I think
actual
it's like
value.
this.
You change 2 variables, front and rear, I believe.
Yeah, but then okay, I think instead of
I'm,
us
like,
trying to
doing this
brainstorm for
I'm
ourselves,
doing this like off like
off the
recall from
fly,
like
yeah,
2,
this is
3
like
years. It's like 3
exactly.
years ago.
I
Recall.
haven't had a reason to use a circular queue. I only got it in one interview, and that's about it. Now.
Yeah, just saying. Okay, YouTube.
Yeah.
Yeah. Yep. YouTube and Geeks. Actually, here I'm actually put a link in the chat.
Yeah, that's a good idea.
There. Actually, I don't know why that.
Am I still streaming? Close it.
Actually, I think this is the link. Oh, whatever. It broke. I don't know. It's Geeks for Geeks. You guys should be very familiar at this point. Geeks.
Okay. Yeah, you guys see what happens when you're trying to come up with answers for certain things on the fly.
Yeah.
Sometimes these things are hard to pull out of your old treasure chests of memories, you know.
See.
Let me see how much time do we got. All right, we have We have 35 minutes. So we're
20.
not working right now. We're in school. As far as I know, we're basically in school. We're just doing our own thing. But yeah. What about you? Are you in school right now? I mean, you're here for the review session, but are you trying to get into co-op or an internship just outside of the co-op program? Yeah, of course you're in school.
Oh my-
Hopefully, okay. I'm gonna give you one little advice. I say it a lot. I'm not gonna go into it. Don't rely on just the co-op system, okay? Go and look and apply on your own job search. Use LinkedIn, use whatever. Don't only look in Canada, and you'll find a lot more opportunities and potentially a lot better, okay? The co-op system happens to be a bit of a funnel. You'll
Yep.
come to understand. Rob, do you want to like add on at all or no?
No, I don't want to get into the can of worms.
Yeah, it's a can of worms talking
Yeah.
about co-op. Well, I guess if you could find our GitHubs, you could check out some of the projects we've worked on. You if you I mean you guys know our names, you could probably look us up if we have stuff on LinkedIn or wherever.
Interesting projects. Any ideas?
No ideas for you, man. Sorry. You gotta come up with some of your own.
No.
Not for free.
Is
Yeah,
Pep
I'm not.
fire? I don't know.
I'm not even. All I know is PEP is longer than just a normal co-op term, right? But it's like
12 months.
it's such a specific thing. It's like, if you do well at an internship anyway, they'll want to offer you a spot again. If you tell them like, hey, look, I'm also hoping to do maybe an extended co-op, like internship, they'll probably be like, oh, sure, yeah, we have space. It might not be the case, but all PEP is just like getting to work a longer term. That might be a bad.
I've even heard of it.
Yeah, so exactly. A lot of people don't even know what it is. I didn't for a while. It's in some ways maybe actually I'll tell you something from my personal experience. And Rob, you tell me if it's been the same for you. After coming back from my internship, my first internship, I was like it was hard to get back in the swing of studying because you feel so like it's such a great experience like getting to work and then like just the work process is like freeing compared to doing school. So it's hard to get your headspace back. So 8 months might make it difficult. I
12, I
don't know.
believe.
It's like breaking up with a girlfriend.
Yeah.
Like,
Yeah, it is.
every year you're together, it's like a month. You have to recover from the breakup.
It adds.
Probably the same way with a co-op term.
And your bank account just goes net minus, net negative. Instead of you can't. Yeah, basically. Let's see. I think maybe let's do this. I'm gonna have a look at which sections we could probably talk a little bit, just a tiny bit. Let me look.
If chat doesn't have any recommendations, of course. Anything they want to see. Obi's frozen. I'm just noticing.
It looks like he's about to sneeze.
Yeah. Maybe it's better if I turn my camera on. Actually, that's fine. Right now on stream, it's like you two are like huge on screen. I'm like in the corner.
Do we have sub notifications? Like, what if I subscribe right now? What happens?
Actually, we do have new followers.
Oh, okay, let me unfollow and follow again. I want to see my name. Anything for the clout.
Exanimate followed a few seconds ago. IMK E June. Imki June. I don't know if I'm saying that right. Followed just now.
Sorry, I
Terry
dropped
again
out for a
followed.
second.
Yeah, a bunch of people actually followed. Sweet. And if you haven't, definitely do follow. I'll plug that right now. Definitely follow.
Did I miss anything? Cause
No, you were talking,
Yeah,
or
you're good.
you froze, but I don't know what.
my laptop died.
Oh,
Let me go back. So I said we could talk about a couple things a little bit better.
you guys stream any games on here? I don't.
We
No,
don't stream
we
games,
don't. Nope.
Should we?
Should we?
but
Yeah.
we've already thought about it, and we're still thinking about stuff like that. But stay tuned. We're trying to do some cool stuff for the club and for the community, especially.
Oh, cool math games.
Bro, cool math games isn't even a thing anymore, I swear.
I think it works not anymore. So, cool math games, like you guys tell me if I'm wrong, they discontinued Flash in 2018.
Oh,
And so that's why you
right.
can't run straight from the cool math game site. But there's some emulators you can use, I'm pretty sure. A lot of it, I'm 100% sure you can use.
Shot.
But yeah, I mean, I don't know if you guys want to watch us play like,
Run.
Fireboy and Water Girl or something like that. But
Oh,
like,
that'd be so
Nah,
dope. Oh my
run.
god.
yeah, there's some good ones on that. I don't know if you guys knew Monkey Games. There was like a zombie, it's a zombie game. It's like the best like 2-player like zombie shooter. It's so fun. It's like a little block dudes, and you have waves of zombies, and you set up like barricades. But it's like COD, but like stopping zombies coming from you at you. All right, I don't know right now. I think okay. I'm gonna ask in the chat. Okay, I'm gonna go step by step.
Was it called Boxhead?
Box head, the rooms.
Oh my god, bro. I just looked at the images and now I remember what you're talking about. Oh my god. That game slaps.
That game is fire. I used to play that so much with my brother. Oh my god. Yeah. So let me see.
It's way too loud.
What? Oh,
I'm streaming it.
is my speaker,
It's
bro?
doing a run.
Real quick, can you guys hear echo from my speaker?
No.
No?
I pulled up cool math games and I'm streaming Run.
Yo, Steven, can you hear echo from my
No. You're good. You're good. You're good.
Cool, that's proper. Oh yeah, I remember this game. Wasn't there one with like a green ball that's like rolling down like a Tron like world, and it's like you have to dodge stuff with the ball.
Oh, I don't
It looks like this
remember.
game kind of, but like green and like Tron looking. Speedrun, I think that's this game, I think, right?
I don't know.
Yeah, this shit I was always like, oh man, like bro,
This was
it's so
this was like supply teacher and you're like on the computers.
nice.
You
I
ever
remember actually when it came out, I remember it was like a new thing when it was on like cool math games and this site and everything else.
you,
I
you ever
remember when
just
it
like
actually came out.
you ever just like gaslight your substitute teacher and like, oh yeah, like our teacher said that
100%.
we were like doing cool math games today or
Oh,
something.
definitely, bro. Yeah, we definitely did that shit. Yeah. It's fun times. A better time for real.
Yeah. But does anyone have any more questions in chat while I speed run?
I'm gonna go actually like this. Let's do it like this, okay? I'm gonna list the different things we talked about to you guys, and I'm gonna list them in the chat. Or Rob, can you actually type them down, the big bucket points I'm talking about?
Yeah,
And then you guys just like tell us, do you want us to talk about a specific one? And say, can you talk more about X? So what we talked about was a few different big buckets, right? Let's start with the session one stuff. Okay, we talked about classes. Can you type all this in like a list and send it, Rob or Steven?
Yeah.
So we talked about classes. What are they? Data structures, etc. So classes, data structures, my bad. And what was the last one? Abstract data types. And then in the next review session, we talked about stacks. We talked about queues. We talked about lists. And then in the next one, we talked about big O and some time complexities to know. Anything in those things that you want us to go over?
Someone put a time complexity question in chat.
Steven, can you read out this question?
I can read it out if you want, unless.
Yeah, can you help me with this question? Prove that the problem of finding an element in an array having n elements has a lower bound of omega log n. You can use a technique similar to what we have done in class for proving the lower bound for sorting algorithms.
Did you guys actually have to like? Because I had to do this for algorithms
Design.
last term, but I don't know if you guys do they ask you specifically these types of questions? Is this a question you got?
There's no proofs of like
Yeah.
of big O or algorithm analysis whatsoever. It's just like
Not in first year at least.
No.
yeah,
Not in
no,
first and
definitely
second year.
definitely.
Yeah.
You like
Oh, it's extra. This is extra. He's just curious. Okay.
Yeah. Okay, so there's a couple things. So most of you are not going to know this, but you'll learn it in algorithms class. There's ways to prove the algorithm complexity and like actually get a good read on like how complex it is. So the basic way you do it is there's something called the max rule. And if you look inside of an algorithm, say there's a bunch of different, like maybe a bunch of for loops, maybe some nested for loops, whatever has the maximum time complexity of all of those things inside of it is the time complexity of the whole operation. Basically, like the weakest link. Whichever one is going to take the longest, that's the time complexity for the whole thing. Now, when it comes to proving that an element has a lower bound of like omega, that is some annoying stuff that I can't even fully remember. It just happens to mean like something like if you use X number or a value between the X numbers, it'll be like faster than if you use a value between some other set. I'm having trouble, but like that's not really easy stuff to talk and explain without either being Professor Zima or knowing your stuff really well. So like, yeah. Yo, did you guys get a? I'm just gonna type it myself. So we talked about classes.
no, I
He did type it.
Yeah.
Data structures,
Oh, you
ADTs,
did?
stacks,
Okay,
queues,
cool.
lists, recursion, big O.
Okay, perfect.
Another hard question.
We're only gonna do so many of these hard questions.
Yeah.
My brain will explode back on you. It'll only make it harder for yourself.
For every
Rob, do you want to take it?
For every n greater than 1, there are n element arrays that are sorted faster by insertion sort than by quick sort. Hold on. Whoa.
For every n x greater than 1, other
That
n
should
element arrays that are sorted faster by insertion sort than quick sort. I don't know the answer to that.
So
pretty sure it's
I know that there's different speeds for different ones, and I'll tell you why for certain of them that I can remember. But
they're
I guess
faster by insertion.
it would either here's the two cases that I could see there being a different like speed that one might do better than the other. Maybe you have say
Cheating.
an array that has only two values, or some array that has a big number of values. Maybe there's some way one of these sorting methods does a better job at sorting these values than the other. But it only happens once you get to like a bigger value or a smaller value. So I don't know exactly, but that's the only situation that I would think to look inside of and see if that's like how if one works better at handling bigger lists than smaller lists. That's what I would check for. But I don't know. That
This
is
has to be
definitely
312. Yeah, this seems like some
this
312.
is 312. This is definitely 312 stuff. Yes, it's 312. Don't stress yourselves about this. Yeah.
Do you think they'll ask this question on the exam?
No.
Absolutely not.
Someone
Not
already
even like
said that big O in recursion is not on it, right? That's what someone had
But-
already said.
which is weird. I like completely thought that
I thought Big O
Big O and
was.
Recursion were both. Big O was 100% on it. Have you guys not been having
Goes on.
about Big O like almost every week? Like just about functions that you've like encountered in lab or lecture or assignments throughout the week. I don't know what Big O is.
Oh.
Damn, Rob. You're making me want to get cool math games open right now. Oh man,
Still going.
some bangers.
I was always a run 2 guy myself, not really a run 1 guy.
Yeah, run 2 is better for sure.
I couldn't find Run 2. Is this it over here?
You know, it was a
there
time
it
when
is.
like it was a time when they would make like a second game for like a series. The second game was actually better than the first one. You know?
Yeah. So much more immersive with the 3D blocks.
Yeah, facts. Yeah, David Brown is pretty chill.
Yeah.
David Brown is super chill.
Goated.
Bro, I didn't know how tall this guy was. That's why I met him.
Well, Brown, how
Yeah.
tall is he? Was he
I
like?
don't know,
Oh, yeah, he's like
6'5".
6'3". Yeah, he's pretty tall. I remember.
Yeah.
I remember.
Oh, didn't see that.
Yeah, he has a dope beard. I don't know if he shaved it. I can't remember.
It's a technical section here.
Really quick chat. Can you guys tell me the different first year profs you guys have for like, I guess this class?
Oh, I think they have this new prof named Erin Meager. She's my discrete math prof. She's really, really good.
Safa, I know that. Aaron, say her last
Aaron
name.
Meager.
Meager, I'm not really sure.
Thought you were going on some anime shit right there.
Aaron Yeager?
Aaron Yeager. I haven't even heard of her, but I think she's new.
Yeah,
Safa,
I think the first year.
I think is Safa's first name Mohammed?
No, it's Safa. That's her first name, Safa Bedoui. She was my CP164 prof. Pretty sure.
Yeah, you guys
I
have a
haven't
little.
heard of any of these people.
Yeah, I think these are new profs.
Yeah.
Old profs were like, forget this online stuff, man.
I think the reason is, I don't know, they always give the first years the best profs.
Questionable.
Really?
But
who's an upper year prof that's better than like D
well,
Brown?
Brown wasn't the only one. Like he was good. Obviously, like one of the best, if not the best. But like some of the other ones weren't as good, nearly as good. Like you go and not be able to pay attention to the lecture. You know, it's one of those types. I have one of those profs, but Badawi. So who's your favorite prof out of all these people? Like, do you guys like whoever has each of these profs? Like, are they good or bad?
Rate my
In your
prof right
opinion.
now. No.
Rate your prof here right now.
Yo, Rob, start a poll. Best prof.
Best prof.
Hard
Bro,
to tell online.
I don't know how to do that.
Actually,
No,
yeah,
play.
that'll be
Damn,
fun.
you're on level 14, dog?
Yeah, bro.
We still have time for the actual
If you
review.
have questions,
But if
yeah,
you have
please.
questions,
I'm
answer
just
them.
killing time playing Run.
We're all killing time. Yeah. Let me see.
How do you invert a binary? Oh my gosh. You guys have not covered that yet. That's a trap.
I think you're like
Yeah.
a solid year ahead of every person on trying to learn this because you're probably looking at internships or something else, or you already know this stuff from high school, so you're like, it's time for the next thing.
They're just in here smurfing. That's all.
There's just 100,000 like videos on YouTube about how to invert a binary tree. Like every single algorithm tutorial is about how to invert a binary tree. Like you're good.
True.
You can program Linux, and how do you read from the command line when programming in Linux? Sorry. How do you read from the command line? With your eyes.
Yeah.
Who is this guy?
Yo, wasn't there another game website? Well, first of all, you don't use Eclipse unless you have a good reason to. For like
Oh my god!
No.
You update it as often as you feel you should, as often as you need to. As long as it's not breaking your computer, you should be okay. You should be okay. But what was I saying? I'm saying, I know, if you have a real question about like the review session, go ahead. But what's the other like website? There's a few. Like there's Armor Games or Armor Games. There was
Y8.
there's like Fuji games. It was like Fufu or Fu. There was
Mini
Fubu and then
club?
like another. It was like there's a couple and they were like, all like so like all the same. Like there were two or three that were almost identical. It looks like a grid of games that you can select. Ninja Sheep, I think I played that. There was like those Stickman games. Do you guys remember those?
Yeah.
Those were like, those were so
Oh.
fun. You play those? Do you play those a lot?
Like who, me?
Yeah, did you play like those
The
Stickman games?
Stickman?
Let me see.
Yeah, I used to.
Stickman fighting. That was so fun.
Okay, yo, somebody asked.
Priority
A
queue.
lot of people asked if we can priority queue. So
Okay.
priority queue is like a pretty simple concept. It's kind of like a queue, but the first, like the one at the start, so like queue is first in, first out. So the first value changes based on how big the value is, or how small the value is. No, how big it is. That's right.
I'll clarify that and I'll let you finish explaining. The premise behind a priority queue is that each item in the queue has some sort of value or an attached value that tells us whether or not it's like important or not. So the way that to make things simpler for you guys and in this class is that the priority queue is just based off the value of the item itself. So like if the item is value one, number one, that is the highest priority, and then that gets pushed to the front of the queue. So you want to take it away?
Yeah.
And
So
good example, by the way, is emergency room. If you want to talk about an example like that or something.
yeah. So so whenever you insert, you're just gonna have to update the first value based on like the priority of the value that you're inserting. So for example, let's say, so when you're inserting a value, if your first is none or something, you always set your first to 0. And I don't know how to explain it, but like if the value that you're inserting is greater than the value at the first, you set the value of the first to the end of the list so that the value just entered is now the top of the queue. I don't know if that made much sense, but like you just want it in like prioritized. So ones with the biggest highest priority are exited first, like Obi said. So like it's not much, like the coding itself isn't much different from the queue, but you just have to take into account that you want them in that certain order.
Yeah.
See if I can pull
So every
something
time, Rob, do you want to explain?
I didn't have anything else to explain. I was just gonna pull something up.
Okay, I heard you go.
Oh, we know you've never played Nitrome games, brother.
Nah,
Go.
but there was mini clip.
Oh, that's true. Mini.
Yeah.
Oh my god, Nitrome was always featured on that.
Oh, there was also Ancon or something like that. It was like an ants. It was ants. It was like an ant logo.
Oh yeah. That was like a forum too. You could like post stuff
Yeah.
on. There was so many.
That was
The
fun.
bot keep
Raft Wars.
I think the person said thank you in all caps and the bot just freaking timed them out.
Damn.
Oh, Raft Wars, bro. Oh
Yeah,
my
Raft Wars.
goodness.
I remember that one, bro. That was fun. That was fun.
So fun. Holy crap.
Like some of these games still hold up really well too.
Yeah.
Oh yeah, you guys remember Hanger?
Stop spamming.
Did you ever play Hanger?
No, I never played Hanger.
The bots popping off,
Well,
giving people timeouts in chat.
yeah. Somebody threw a bot on our chat, and our
No,
bots.
there's a night bot. There's like the mod bot, whatever, for like spamming stuff or whatever. I don't know. It's kind of harsh. I'm not gonna lie.
Oh shoot, that's loud. Oh my gosh, bro. That was probably a virus or something else. I opened a game. It's not the right hanger though. Let's see. Hanger game. This one is like your stick man and he's swinging. You have to like get momentum.
Anyways, though,
Anyway,
we are at 9
we are at
o'clock,
time.
so
We are at time.
are out of time. But it's been a slice.
It has been a great session. I want to say thank you to everybody who came out. We hope we were able to provide some needed last-minute value for your exams, and hopefully some other good advice, because Robert and Steven do have great advice. So thank you guys for coming. And if you haven't already, make sure you filled out the sign-in link, and then there's a final feedback link in the Canva link we sent you to go give us some feedback, because we really appreciate it, because we use it to actively make things better for our review sessions going forward. So thank you, and also keep your eye out, because we have our midterm review session, meet the recruiter session coming up. Rob, when is it?
16th, 14th. One
Seven-
sec.
17.
17th.
17?
Okay.
Ah,
All
wasn't
the
that?
details. If we're wrong about any of these dates, you can find them on the
IG.
Discord.
Or yeah. on
But
Discord.
anyway, thank you guys. Much love. Much
Yeah.
love.
Thank you, everyone. Peace.
Till next time, guys.